Hello viewers, welcome to a session with Ms. Taylor. Today we're going to go over some simple acid-base calculations, specifically those involving ion concentration. Now, I have some equations listed up here at the top. The four in black that are listed as given equations will be on the test for my students. These also happen to be four of the given equations on the equation sheet for the AP Chemistry test. That's why I give them. Over here in red would be what's not given, nor are they given on the AP Chemistry equation sheet. This is how you undo a log. Notice that pH and pOH are the negative log of their respective concentrations. Well, if you've got this, how do you get back over here? Well, you do 10 and raise it to the negative pH or pOH that you have, and that'll get you back to your concentration. So the problems we're going to do, we're going to see how to manipulate these equations to get what we're looking for. We're going to forego the simpler equations where it's just plug this in, negative log of that gives you pH. We're going to do some two-step equations after the first example, just to get our feet wet. So let me scroll down a bit. Our first example, we want to determine the hydrogen ion concentration in a solution that's 4.3 times 10 to the negative 10 molar in hydroxide ions. So let's write down what we know. We know we're looking for this, and we've got this. Now, if you'll refer to the equations up there at the top, once you know what you're looking for and what you actually have, go back and look at your equations and compare. Okay, we have OH and we're looking for H. Well, our first equation is going to fit the bill because we have this one, we're looking for this one, and their product equals a constant, Kw, which is also the autoionization constant for water. So I'm going to scroll down a bit and finish working out this problem. So I'm going to set 1.0 times 10 to the negative 14 equal to the concentration of the hydrogen ion times our given concentration of hydroxide ion. And then to solve that, I'm going to divide both sides by that hydroxide ion concentration. And since our given concentration has two significant figures, our answer should be written with two significant figures. So when you punch that into your calculator, be sure that you put parentheses around the scientific notation and that you use the correct scientific notation buttons. If you're not sure what I'm talking about, you need to Google how to do scientific notation for your brand of calculator. But if you do this correctly, you should get 2.3 times 10 to the negative 5 molar. Be sure that you're rounding correctly and that this is a molar concentration, so you write the molar symbol next to it. Alright, let's move on to example 2. Alright, now we're going to get into the multi-step problems, and there's more than one way to solve these problems, so I'm going to show you both ways. So first, reading the problem, we're going to determine the pOH, so that's our unknown, of a solution that we know the concentration of hydrogen ions is 5.8 times 10 to the negative 5 molar. Now, if I had given you the OH concentration, we just would have taken the negative log of it and we'd have the answer. But I did not. So this one has two ways to solve it. So I'm going to write method 1 over here. Looking at this, you may be thinking, well, hey, we just used that Kw equation to get the hydroxide ion concentration, and I know I need that to get pOH, so let's try it. Do 1.0 times 10 to the negative 14 equals the hydroxide ion concentration we need to get pOH times 5.8 times 10 to the negative 5. And then we'll divide both sides by that value in order to isolate the concentration of the hydroxide. Oop, started to write the wrong thing. So if you put that into your calculator, this concentration should be 1.7 times 10 to the negative 10 molar. From there, we know that POH equals the negative log of the hydroxide ion concentration. So I'm going to plug in that previous answer there. And then your final answer should be 9.76. Now, before you go, wait, that has 2 sig figs, that's 3. When you're doing acid-base calculations involving pH or POH, we have its own special rule. If there are 2 sig figs in your concentration, that means there's 2 decimal places in your pH or POH. A little weird, but it has to do with the fact that the pH and POH scales are logarithmic, so that keeps us from over-rounding, I suppose. Now, let's look at method 2. We could say, well, since we have the hydrogen ion concentration, we can solve for pH and take the negative log of 5.8 times 10 to the negative 5. So we would get that our pH equals 4.24, again, rounding this to 2 decimal places because this concentration has 2 sig figs. And then, if you refer back to the equations at the top, pH plus POH equals 14. So I can say 14 minus 4.24 equals my POH, which is, again, 9.76. So you may be looking at that and going, method 2 is a whole lot shorter. Yes, it was, but you got to the same answer either way. So, as long as you get the correct answer, that's all that counts. Alright, let's move on to example 3. This time we're sort of doing the opposite problem of example 2. This time we're looking for pH, but we are given the hydroxide ion concentration, 2.3 times 10 to the negative 8 molar. Now, the 2 methods of solving are pretty much what you saw in the previous problem. So for method 1, I'm going to use the KW equation to help first, because pH requires the hydrogen ion concentration, and I can use the KW equation to solve for that. So then I'm going to divide both sides by 2.3 times 10 to the negative 8. And that gives us a hydrogen ion concentration of 4.3 times 10 to the negative 7 molar. And then pH is simply the negative log of that number. And before we round our answer, since there are 2 sig figs in this concentration, there should be 2 decimal places on our answer. So our answer is 6.36. Now, method 2, again, same way as method 2 in the previous problem. Since I have the hydroxide ion concentration, I'm going to solve for the POH by taking the negative log of that concentration. And that gives me a POH of 7.64. And then since the sum of pH and POH is 14, I can subtract this from 14, and I will get 6.37. No, actually that one will be 6.36. Maybe it was that one that was supposed to be 6.37. Hold on, let me check. Sorry, had a little mistake there. That one should have been 6.37, and this method gives you 6.36. Now on the test, I would realize that you get 2 different answers, albeit ever so slightly different depending on which method you chose to solve the problem, and I would give you credit for both of them. So we're going to move on to example 4. Alright, now we're going to go in the opposite direction. We know in this problem that the pH is 5.55, but we want to know the hydroxide ion concentration. So, again, 2 methods to doing this. So method 1, we can undo this pH by saying that our hydrogen ion concentration is equal to 10 to the negative 5.55. And that should be 2.8 times 10 to the negative 6 molar. We're trying to get to the OH concentration, so here I'm going to use the Kw equation. And plug in the value we just solved for the hydrogen ion concentration. And of course, we're going to divide both sides by 2.8 times 10 to the negative 6. And that will give us our answer, which is 3.6 times 10 to the negative 9 molar. Now, going back the other way, I know you're looking at that and go, wait, that's 3 sig figs. This is 2 decimal places, therefore this is 2 sig figs. We got that weird concentration decimal place rule. Alright, so that's one way to solve it. Here's another way. You could say, well, I know pH plus POH is 14, and if I have POH, then I can get hydroxide. So we'll say 14 minus 5.55 gives us POH, which is 8.45. And then we can say that the hydroxide ion concentration is equal to 10 to the negative 8.45. And if you plug that into your calculator, you will see that you still get 3.6 times 10 to the negative 9 molar. Either way is correct. One more example, similar to example 4. We know the POH, but we want to know the hydrogen ion concentration. And again, there's 2 methods to solving this. So the first method, I'm going to say, well, if I have POH, then I can undo it to get the hydroxide ion concentration. So if you punch that into your calculator, you should get 1.43 times 10 to the negative 10 molar. And then we can use that Kw expression, that relationship, to solve for our missing hydrogen ion concentration. Oop, left off my 3. So then we're going to divide both sides of that equation by 1.43 times 10 to the negative 10. And that will give us our answer. And looking up here, we had 3 decimal places, so that means our hydrogen ion concentration should have 3 sig figs. So we get 7.00 times 10 to the negative 5 molar. And then method 2, we could look at this and say, well, if I have POH, then I can get pH, and then I can get the hydrogen ion concentration. So if we do 14 minus 9.845, we get the pH, which is 4.155. And then we can get the hydrogen ion concentration by saying 10 to the negative 4.155. And it does give you the same answer, 7.00 times 10 to the negative 5 molar. Make sure that you are rounding things correctly. Make sure that you are putting that molar symbol if you're solving for an ion concentration. I hope this helps. Good night and good luck.